All right, we're rolling. Okay, in the example, it says determine the intervals over which the function is increasing, decreasing, or constant. And then we're going to determine whether the function is odd, even, or neither. So something I need you to write down. We describe increasing, decreasing, or constant using x values. Okay, so it's going to be important that as you're describing increasing, decreasing, or constant, we use x values. So we need to make sure we're doing it the same way. So when we look at f of x equals negative 3x squared minus 2x plus 1. I want you to take out your graphing calculators, and we're going to go to our y screen, and I want you to pop that function in there. Negative 3x squared minus 2x plus 1. And I don't know what I was doing in the last class, so I'm going to do zoom 6 to put it on a standard window. And looking at the equation, we could have pretty much been able to tell this was a parabola that opened down. And so if you look at this graph, it's increasing, increasing, increasing till we hit this maximum point, and then it's decreasing from there. Okay? So what we need to do is we could do it algebraically to find that vertex, x equals negative b over 2a. Or, I just want to practice that you know how to use this feature on your calculator. Let's do second trace, and it's what we refer to as a relative maximum. So we're going to press 4 for maximum, and then you get a little bit to the left of that maximum, get a little bit to the right, and then just press enter on the guess. So it's telling us the maximum is at negative 0.333 repeating, and at 1.333 repeating. So this is the point. Is that negative? Yeah, negative point. Well, yeah, that's negative 3 repeating and 1.3 repeating. So here's how you're going to describe increasing and decreasing. We use interval notation. And it's increasing from the left until we hit this value. So we're going to say that's negative infinity. And don't we know that 0.3 repeating is 1/3, that fraction? And then it's decreasing from negative 1/3 to infinity. And the reason why we don't use a bracket at the negative 1/3 is that it's not increasing or decreasing there. It's actually switching what it's doing. What we mean by constant is that if I had a graph, I don't know, I'm just making this up, that here's where it's constant is that horizontal line. I mean, it's not at an instant, but it's on an interval, okay? So I did not have anything that was constant here. All right, g of x. Let's go ahead and put this in the calculator. So go to your y screen. G of x was x cubed plus 3x squared. Now I'm on the standard window. And you can see that we have a relative maximum and a relative minimum. We have both. So let's go find both of them. So I'm going to do second trace, and I'm going to do the maximum first. I'm going to start on the left side of the graph. Press enter, enter, and on guess just press enter. So I'm getting a maximum at negative 2, 4. So just jot that down for now. We'll make a little sketch. And then do second trace. We'll get the minimum. Something I want to refresh your memory. When we're doing problems that involve decimals, we're always going to round 3 places unless you can write it as a fraction. Okay, now this is interesting on the calculator. The minimum on mine in the previous class, they said their numbers were off a little bit, but they were essentially getting the same thing. What does this mean? X equals negative 1.724e negative 6. Tyler?
So it's times 10 to the negative 6, so it's pretty small.
Yeah, it's scientific notation, right?
Yeah.
So this really means negative 0.00000, and you're absolutely right, it's awfully small. And I have to remind you, I know you already know this, but humans programmed the graphing calculator. And as they were doing their programming, it's estimating, and then what happens is the estimate is that far off from actually getting 0. So this is a human error, and it's something you need to understand about your calculator. So essentially, this is 0, 0. This one's even smaller, the y value, right? That's 0.00000 with 11 zeros, and then 8915. So let's make a kind of a rough sketch here. We had negative 24, and then we had a 0, 0, and it was coming up like this and bouncing off, okay? We're not looking for perfection whatsoever, but just a rough idea. So what's interesting is my graph increases from negative infinity to negative 2, then it starts to decrease in between negative 2 and 0. Remember, we describe increasing, decreasing, or constant using x values, and then it starts to increase again from 0 to the right. And then we show that it's decreasing from negative 2 to 0. And I think I forgot something. I just caught myself here. I forgot to do the even odd, so we'll do that now. But does this make sense, our increasing, decreasing? Pretty easy. Now, if you want to determine whether a function is odd, even, or neither, all you're going to do is replace x with negative x. And see if you get the original function back, or do you get the opposite of the function. So this is negative 3x squared plus 2x plus 1. Is that identical to the original function? No. Is it just everything is the opposite? No. So it's neither. Now, based on what we learned yesterday, graphically, what should happen if it would be even? If it's an even function. Tyler?
Should have y-axis symmetry.
Yeah, and think of it. When I say even, try to think of x squared. X squared, okay, that's symmetric with respect to the y-axis. So if I were to, and what's really cool, since I took mine out already to do the next one, did you notice that this was just shifted a little bit to the left of the y-axis? So if we tried to fold it on the y-axis, it doesn't have y-axis symmetry. And then what graphically does odd mean? It wasn't x-axis. Origin. So take your graphing calculator.
Good guess.
Okay, it was a good guess. Good guess. But if I take my graphing calculator and I turn this upside down, it doesn't look the same. So it actually doesn't have origin symmetry. I can already tell, but let's prove it algebraically. And we are laying wonderful foundation for calculus. Is we want to do things algebraically, we want to do them graphically, and we want to look at them analytically or numerically. So really cool stuff. All right, in the next example, I want to give you a moment, and we're using this word, and let me redefine it in case we have forgotten what we mean by a relative minimum or a relative maximum. If I go back a screen to here, this point is what we call a relative maximum, because if I looked at the whole picture globally, the whole thing, the maximum goes to infinity, doesn't it? And so when we're talking about that you have a hill, I like to refer to it as a hill or a valley. If I have a little hill, then that's just, relatively speaking, that's a relative maximum. This point down here isn't the minimum, it's not the lowest point I have, because it's going to shoot down to negative infinity. But relatively speaking, I've got a little valley, and so that's a little low point. Okay, does that clear up maybe what that means? All right, use your graphing calculator, and I want you to find the relative minimum, relative maximum using your calculator. We just reviewed the buttons. Please round your decimals 3 places. 3 places. Remember again, round 3 decimals. So on part A, I have a relative minimum at 0.333, comma, negative 5.333. Okay, looking at letter B, something I want to point out to you is this really is not a good looking window. And you should, as a pre-calculus student, begin to understand when you're using your calculator that you can make adjustments to this window. This is just taking up a teeny tiny space. So I'm going to press window, and I'm going to go -2 to 2. And I'm going to make it have a scale of 1/2, which means I'm telling the calculator to plot -2, -1.5, -1, -0.50, 0.51, 1.52. And let's take a peek at this. And this is a much better looking window, okay? So you can mess around with that. So we have both a relative maximum and a relative minimum. So let me write both of those down. My relative maximum, I had -0.224, comma, -1.619. And I had a relative minimum at 0.558, comma, that rounds to -3.53. Okay, remember, go 3 decimals. You guys get that? No problems. Okay, next example. Write a linear function f for which f of 2 equals 4 and f of 5 equals -1. So, can somebody state for us, what does f of 2 equal 4? Just this first piece. f of 2 equals 4. Tyler?
It's like a point. It's like 2, comma, 4.
Exactly. f of 2 equals 4, we need to recognize is just a point. And then f of 5 equals -1 is just 5, comma, -1. So how would you write a linear function for this? What would you need to find, and how would you do it? John?
Find the slope.
Okay, let's start there. Let's start with, we'll find the slope. So I'm getting, series. I know how to subtract, really. Okay, let me try that again. Woo! Okay. And I'm recording this. Okay, so we get -5/3. Then I would like to encourage you to use point slope. You don't have to, but this will really help When you get to calculus, we use it often there. So pick either point. I'm going to pick the first one. And you get y minus 4 equals negative 5/3 times x minus 2. Okay, I'm using point slope. I'm going to go ahead and multiply both sides by 3. If I do that, that'll cancel the fraction, but I do need to distribute the minus 5. So I get minus 5x plus 10. Add the 12. And then divide by 3. The advantage to point slope is I didn't have to deal with a fraction until the very end. But if you do y equals mx plus b, you're going to have to be subtracting, getting common denominators and all that. You're welcome to it if you like fractions and like that, go for it. But I'm just trying to show you a different way to do it that might be a little bit easier. All right, any questions up to this point? Doing okay. All right, the next example, f of x equals, and this is referred to as the greatest integer function. And what they mean by the greatest integer function is that what is the greatest integer less than or equal to the given number. So for example, if I put 1.8 inside here, what is the biggest integer that's less than 1.8 or equal to it? And it would be 1. Because it says, what is the greatest integer less than 1.8 or equal to it? Well, the biggest integer is 1, not greater than, and it's not a rounding thing. So then if I said 1.1, this is still 1. If I do 2.5, this is 2. If I do 8.3, this is 8. If I put in a whole number, that's what they mean by greater than or equal to, or the greatest integer that's less than or equal to, so that's a 4. So let's look at the graph of this, and then we'll talk about the telephone company, and we'll talk about the post office. There are a lot of places that use this. And then I'll show you on your calculator how we can graph it as well. So if I plug in any number between 0 and 1, it's really going to go down to 0 until I hit 1. When I hit 1, it jumps. Sometimes we refer to this as a step function. Like so, okay? So it looks like stair steps. Now, how the telephone company uses this is you might be charged long distance a rate up to, say, the first 10 minutes is $1. And then for the next 10 minutes, you're charged $2. So that's like greater than 10 up to 20 minutes. And so you can see where those rates are flat, but for a period of time. So, and I don't know what the post office package sizes are, but it's something like, so much to an ounce is 44 cents. And then when you're from like so many ounces to the next weight, it goes up another flat rate. And so does that make sense where we're doing these horizontal pieces? All right, so let's look at your graphing calculator and clear out what you have in y1, and let me show you where the greatest integer function is. So we can see these with the calculator. If you press math, okay, press your math key, and arrow to the right to the column NUM, and then number 5, INT, stands for greatest integer. So then we're going to put an X, and then remember I played with my window, so I want to put it back on the standard window. Let me repeat that. You do math, arrow to NUM, and go down to INT. Now I'm going to do zoom 6, and it looks like little stair steps. I had somebody in the earlier class who had theirs were connected, and I couldn't unconnect it for them. I'm not quite sure what was happening there. Now, this is just for fun. Well, let's go back to the Y screen, and in Y sub 2, let's put a negative in front of the greatest integer. So those of you that like to mess around with pictures, this can give you some creative ideas. So you can actually make what looks like an X. You can do all sorts of stuff playing with these, okay? You could probably fill your whole screen if you do shifts and stuff, move them right and left, and just play with your calculators. It's fun. See what happens. But I thought you might like that. I do hear people saying they're playing and showing me different pictures, and I'm like, that's pretty cool. I have somewhere, was it you, Tyler? Somebody who did the Batman. Who did Batman?
Was it Sam? I thought Isaac did something.
Yeah, I forget who it is now, but I have, if you want to be able to get the Batman emblem, and it's very, very complicated what you enter in your Y screen. I mean, it fills up, I think, the whole thing. But you can really do pretty much anything you can imagine on there. All right, last idea is a piecewise graph. Do you guys remember these from Algebra 2?
Sure.
F of x equals x plus 1 when x is less than or equal to 2, and it's 1 minus x when x is greater than 2. What you do is you look at the inequality symbols, and the one that is not equal to has the hole in the graph. And I would recommend starting with that piece. So I'm going to make a column x and 1 minus x, and then you plug in that value it says you can't do. It says x is greater than 2. I'm going to plug in the 2. 1 minus 2 is negative 1, and you need to indicate that that's the hole in the graph. And we're going to plant some calculus seeds with this and be talking about a limit, getting it closer and closer to the hole in the graph. But you're not actually touching it. All right, so x is greater than 2, so let's plug in a 3. 1 minus 3 is negative 2, and let's plug in 4. 1 minus 4 is negative 3. Then let's do the other piece. It says x is less than or equal to 2, so I plug in the 2. 2 plus 1 is 3. X is less than or equal to 2, so let's plug in a 1. 1 plus 1 is 2. We'll get one more point. 0 plus 1 is 1. Alright, so we're going to start with the piece that has the hole, and if you can do that consistently, it will just make your life a little bit easier. So I'm going to start with 2, negative 1, and I'm going to put a hole in the graph. Then I have 3, negative 2, 4, negative 3. Now a question I commonly get from students is, how do you know which direction to draw the line? There's 2 ways I can think of, and maybe you guys can think of something else. It says x is greater than 2. Here's x is 2, greater than 2 is moving to the right. It's not that you can't memorize, I always go to the right, I always go to the left. You have to analyze, and we've talked about that you really do need to analyze what's going on. You have to look at the inequality symbol. The other thing is, the hole is the starting point, and so you're going to go in the opposite direction from the hole. So this is moving to the right, no matter which way you think of it. And then what I was referring to as a limit is, we're trying to think of if we're getting closer and closer and closer to x is 2, like I can get to 2.00000000001. I'm getting as close as I possibly can, and we're going to talk about a limit next year in calculus. All right, the other piece is 2, 3, 1, 2, and 0, 1. So then how do you figure out which direction you go? If you're starting at your starting point, it's going in that direction. Also, x is less than or equal to 2. Your arrows will never go the same direction either. So there's your piecewise graph.